Welcome to Artificial Intelligence. For most of your computer science journey, you have written explicit instructions to solve problems. This unit flips that script. Instead of programming the rules, you build systems that learn the rules from data. We begin with the foundational concepts of Cambridge Paper 3, evaluating the Turing test, distinguishing between weak and strong artificial intelligence, and mastering the complete machine learning pipeline, from raw data collection to training models that can predict and adapt without human intervention.
You will need to confidently categorize how a system learns into three core paradigms. First, supervised learning, where models are trained on labeled data with known inputs and outputs, perfect for regression and classification tasks. Second, unsupervised learning, where the system is handed unlabeled data and left to discover hidden structures, like clustering similar data points. Finally, reinforcement learning. Here, an agent interacts with an environment through trial and error, receiving mathematical rewards and penalties to learn optimal behavior, whether that is playing chess or routing data packets.
The engine driving the most powerful artificial intelligence today is the neural network, inspired by biological brains. You will trace how data flows through these structures. Inputs passed through nodes called perceptrons are multiplied by weights and passed through activation functions. You will learn how the network calculates error and updates itself using backpropagation. When we add many hidden layers, we enter the realm of deep learning, requiring massive computational power to run convolutional and recurrent neural networks.
How do machines perceive our world? Through computer vision, algorithms process grids of pixels to perform image classification, object detection, and facial recognition. But humans communicate with words, not pixels. Natural language processing bridges that gap. You will trace the exact stages of this processing, from tokenizing raw text to understanding syntax and semantics, enabling machines to perform sentiment analysis, translate languages, and power the chatbots we interact with daily.
Not all artificial intelligence relies on machine learning. You will explore expert systems, which emulate human experts in highly specific domains like medical diagnosis. You will trace forward and backward chaining algorithms through a rule base to see exactly how an inference engine reaches a conclusion. Finally, we bring artificial intelligence into the physical world with robotics. You will evaluate how autonomous and industrial robots use a continuous loop of sensors, microprocessors, and actuators to perceive, reason about, and physically interact with their environment.
This unit is explanation-heavy and high-tariff for your A-level exams. Precision in your vocabulary is the difference between a good grade and an outstanding one. You are about to build the conceptual tools to understand the most transformative technology of our time, moving from basic algorithms to systems that perceive and learn. Let us get started.